Dear students, welcome to our science episodes. Today we are going to discuss light energy lenses. Well, lenses. What is a lens? A lens is a transparent medium that refracts the light and is defined with two spherical surfaces and is usually made of glass or plastic. So number one, it's a transparent. It's not a shiny reflecting surface like a mirror. Number two, it refracts light with the R, not reflect light. It refracts light. And number three, it's not a part of only one sphere, it's a part of two spherical surfaces. What is light refraction? Refraction is the change in direction or the bending of light waves when passing from one medium to another. So if you will see this picture, this light rays will travel from air and then will enter this object which is a piece of glass. It will bend. It changes the media. It will bend due to change in its speed. So when the light will change the media, it will change its speed too and bend. This is called refraction. Let's see convex lens. This is a convex lens. It's a converging one. It is thick at the center and less thick at the tips. And the light rays will collect. This means converging. When the light will converge, it will collect. The concave lens is a diverging one, and it is more thick at the tips than the center, and it diverges the light ray, so it separates them away. The convex lens is collecting the light rays at what is called a focus, and the concave lens is separating or diverging the light away from each other. Uses of lenses. Eyeglasses for correction of vision. Watches repair. Laparoscope or telescopes. Microscopes and photographic cameras. We discussed before that lenses, wherever it is a convex lens or a concave lens, they are part of two spheres. The center of curvature. We have here two centers of curvature because we have two spheres. So C1 and C2. And this is the principal axis which passes by the center of curvature. The optical center of the lens is a point inside the lens, whether the lens is convex or concave. So the pole is a point inside the lens, and it lies on the principal axis in the mid-distance between its faces. The radius of curvature of the face of the lens is half the radius of the sphere. So half the radius of the sphere is the radius of curvature of the face of the lens. The principal axis is the line between the center of curvature of the lens passing by the pole, or the optical, what we call the optical center of the lens. Parallel light rays falling on a convex lens, they converge, as we said before, to a point called the focus of the lens, and it is behind the lens. Parallel light rays falling on a concave lens will diverge, will separate away, and they will come from a point in front of the lens. So the extension of these two lines will intersect in a point called focal point, but in front of the lens, and the principal focus of the concave lens, and it's a virtual point, cannot be received on a screen. This is a virtual point, while the focal point of the convex lens is a real point. So which of these two lenses has a great focal length? This is a thick convex lens, and this is a thin convex lens. And you can see here that the thick convex lens is having a smaller focal length than the thin one, because the convexity of the thick lens will make the focal point near to the pole of the lens, and therefore its radius is greater. And what is meant by the radius of a concave lens is 20 centimeters. This means that the radius of the sphere, that the face of the lens is a part of it, is equal to 20 centimeters. So whenever we are talking about the radius of the lens, we are relating it to the radius of the sphere. Let's discuss together images formed by convex lens. Whenever the incident light ray passes through the optical center of the lens, they will not refract. They will pass through the lens without refraction if they will go through the optical center of the lens. But when the incident light rays will hit the lens and they are parallel to the principal axis, they will exit the lens passing through the focus or the focal point. In the third option, the incident light ray passing through the focus will hit the lens and exit from the lens parallel to the principal axis. So again, if the light rays will pass through the optical center of the lens, no refraction. The incident rays parallel to the principal axis, they will refract through the focus. If the incident rays will pass through the focus and hit the lens, they will exit parallel to the principal axis. And here let's discuss the object, the position of the object and position of the image, of course in a convex or related to a convex lens. When the object is located away or at a distance greater or twice the focal length, so the image will be between the focus and twice the focal length. It's real, inverted, and smaller in size. Here, when the object will be at exactly twice the focal length, not greater. Here, greater than twice the focal length. Here, at twice the focal length. So, the image will be also at twice the focal length, real, inverted, and equal to the object. In the third option, the object is between the focus and twice the focus length. And the image here will be at a distance greater than twice the focal length and real, inverted, and larger than the object, the real object. If the object is at the focus, so you will find no image. It's at infinity. The rays will exit parallel to each other. And if the object is at a distance smaller than the focal length, so the image will be, look where is the image? It's here. It's virtual, upright, and enlarged at the side of the object, not at the other side of the lens. It's the same side at where the object exists. Here is a question for you, and illustrate by a drawing. An object is present away from a convex lens by 20 centimeters, and the focal length is 10 centimeters long. So here we go. This is the convex lens. This is the object. It's away from the lens by 20 centimeters. And the focal length, here is the focus. The focal length is 10 centimeters. Dear students, thank you for watching and see you in other science episodes.